in 12b, we've got a function g of x that is equal to 1/2 x to the negative 2. The x to the negative 2 can be thought as 1/2 times 1 over x squared. So it's basically a volcano graph with a vertical shrink of 1/2. So we want to be able to make sure that we can sketch this fairly accurately. Because I have a volcano graph, there are a couple key features that I want to make sure that I have in my graph. And those key features are the vertical and horizontal asymptotes. So I'm going to indicate those with this line and this line. So in our parent function, we have a horizontal and vertical asymptote, and that's where they lie. I also want to generate a few ordered pairs to help me get some points that I can move, my control points that we refer to. So all I'm going to do is, this is going to be for y equals 1 over x squared, the parent function. So if we put in, I'm going to put in a -1, and a -1 squared is 1, and 1 divided by 1 is 1. Put in a 0. 0, if I put that in there, is going to be undefined, so that one's not going to help me. 1, if I put a 1 in there, again it's 1 squared. 1 divided by 1 is 1. And if you want to throw in some others, you can put in a -2. So this is 1 over a -2 squared, which means it's 1 over 4, so it would only be a fourth. If we put in a 2, it would be a positive 1/4 as well. If you want to get some other values in there, where you might want to start squeezing is something like a 1/2. So I'm going to put this in a different color. So I'm going to put in a -1/2. So I got 1 over -1/2 squared, which is the same thing as 1 over 1/4, which is the same thing as 4. So when I put in a -1/2, I get a 4. If we put in a positive 1/2, because it's squared, we also get a 4. So we're going to see some symmetry here. So these are some control points that I can use on this graph. So I'm going to start plotting some of those. A -2 is a fourth. So -2 is a fourth is going to be fairly low. Put it down here. -1, 1. -1, 1 is a great control point for us. That's right here. The other one's right there. I don't know why I put it as a -1 then. Sorry, back it up. This is -1, positive 1. And then we have 0 is undefined. 1, 1 is here. 2, 1/4 is right down in here, kind of low again. Drag my thumb. Anything else I can do wrong? So down in here. And then at -1/2, we get a fourth. So when we get in here at a 1/2, we got to go up to 4. When we get in here to a positive 1/2, we got to go up to 4. So this is what our volcano graph looks like. And we have some pretty good control points inside of here. This point right here, 1, 1. And this order pair right here, -1, 1. We also have some decent control points on the inside. Right here, that's a -1/2, 4. And this one here is a positive 1/2, 4. Those are our best points that we can use to control. So what we have to do to our control points is multiply it times 1/2, which is a vertical shrink. So all of our y values, since it's a vertical shrink, all of these get 1/2 of it. So take 1/2 of a fourth, it's an 1/8. 1/2 of 1 is a 1/2. Can't do the undefined. 1/2 of 1 is a 1/2. 1/2 of 4th again is an 1/8. But 1/2 of 4 is a 2, and 1/2 of 4 is another 2. So what I want to do is I want to take all of these points that I had before, and I want to shrink them by a 1/2. So where I had, and I'll put this in red, where I had a fourth, I now have an 8. It's even closer to that axis. Where I had a 1, now it's a 1/2. And where I had a 4, this 4 shrinks down to a 2. So it's tighter along the horizontal asymptote, and then it gets a little bit flatter inside. And then this one that was at 1/2 goes down a 1/2, because that's this 1/2 right there. This fourth becomes an 8, and this 4 becomes a 2. So once again, we get the same mirrored effect on the other side. So there's the graph. And what I was really looking for were these points right here and right here. They became, instead of a 1, 1 and a 1, -1, they became a -1, 1/2, and a 1, 1/2. And if you could get me these points of, instead of a 1/2, 4, convert it to a 1/2, 2, that gives you just a little bit better precision of your graph. Instead of a -1/2, 4, -1/2, 2. So I'm just taking these order pairs and graphing them. So now that I have my graph created, I can start talking about the domain. So on the domain, what I want to do is I want to do a little bit of a search. The search that I'm going to do is going to be this search from left to right. Whenever I'm dealing with domains, I want to search my graph from left to right and see if I come across any places where it has a vertical asymptote or a hole. Well, we definitely have a vertical asymptote at 0, so that means my domain is defined from a negative infinity up to 0, union that with from 0 to positive infinity. This is the only place that we have any glitch in our domain. Otherwise, every x value can be used. On the range, what I want to do is I want to search my graph from, and I kind of think of it going from low to high and see if we have any glitches or any kinds of things that we can describe. Well, there's never anything below the axis here, so that means all of my values are greater than 0, and they go up to positive infinity. It never touches 0, so I want to make sure it's a parenthesis on up to infinity. Continuity. A lot of you just said, yes, it's discontinuous, it's an infinite discontinuity, but when we describe the continuity, we tell it the interval in which it is continuous. So it's continuous from a negative infinity up until we get to 0. That's where we have this infinite discontinuity. Then it's continuous once again from 0 to positive infinity. So that's what we're looking for our continuity answers. Tell me on the interval in which it is continuous. Increasing, I want you to tell me the interval in which it is increasing. So I know from left to right the graph is increasing from negative infinity to 0. Then, as I jump across the vertical asymptote here, now it starts decreasing. So that's it for my increasing, but now it's decreasing from 0 to positive infinity. Now my graph is falling. Whenever the graph is falling, it tells me on the interval where it's decreasing, and wherever it's going upward is telling me the interval which is increasing. So that's a pretty busy picture. Hopefully you can sort it out as I walk through and talk through it. It would make sense, but I had a lot of trouble with these three things: continuity, increasing, decreasing, and understanding we're supposed to write an interval on which that is happening.